Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandaru. Students, in this Transformers through topic wise MCQ series, we have already completed 3 sessions. It is the 4th one. If you want previous, click on the playlist. You can find out the previous sessions. Okay, let us start the session. First of all, I want to check up to which we have completed in the previous. All these questions we have completed now. All these are topic wise MCQs. Yes, up to this one we have completed. Coming to first question in this session, stacking factor of a transformer is always dash. Stacking factor of transformer is always dash. What is the stacking factor? Stacking factor. It is denoted with Ks. It is the ratio of the areas, net cross-section area of the transformer by gross cross-section area. We know very well net area always less than gross. Okay, so that's why Ks is always less than 1. So answer is option B. Very important question, guys. Very important question. Ks always less than 1. The process of bunching of laminations is called as dash. Process of bunching of all the laminations is called as dash. This one is called as core staggering, guys. Core staggering. Why we are bunching all the laminations? We are going with the laminations to reduce the eddy current losses. Okay, that is laminations are nothing but we are taking a very big core into small cross section area of the cores. Okay, and laminate and bunching them all together. Why we are going to bunching them? If we have a single small core of the area, there is a chance of damage. Mechanical strength is less. So to get a very good mechanical strength, we are going to bunching all them together. Okay, and the process of bunching of laminations is called as core staggering. If you are not doing the core staggering as perfectly, then there is a problem of magnetostriction. That means all the cores may be vibrate, so we will get vibration and noise. So we have to do core staggering perfectly. Leakage flux is more in which type of transformer? Shell type or core type? Leakage flux is more in case of core type transformer. Why? Because in case of core type transformer, we have the windings. One winding is here, another winding is here. Okay, so there is a lot of gap between these two. So that means there is a chance of more leakage flux. Coming to the shell type, one winding upon another. Okay, in case of shell type, one winding upon another, that is LV, HV, HV, LV, like that. Okay, so here in this diagram you can get understand very well. So in case of core type transformer, this is one winding, this is the another winding. So there is a gap between these two, so there is chance of leakage flux is more. But coming to this shell type transformer, one winding upon the another one, so very less air gap. Less air gap means less leakage flux. Okay, less leakage flux. Whenever the leakage flux is less, it can having the property of power transfer, more power transfer capability. So power transfer capability is high. Transfer capability is high in case of shell type. Here low. Okay. So here leakage flux is more in core type transformer. Coming to the next question, in which type transformer copper requirement is high? So from this diagram we can get easily So here two windings, here one winding upon another one, here lot of copper is required. Okay, so here copper requirement is high, here less. Okay, so copper requirement is high in case of core type transformer. So the answer is option B. Coming to the next question. In which of the following which of the transformer sandwich type of winding procedure is used? What is meant by sandwich? Bread, curry, bread, curry, bread, curry, like that. So here, in case of these two transformer, here one winding upon the another one. Na? So if you place LV upon that insulation, HV, insulation, LV, insulation, HV, like that. So these are HVLV are like a bread and this insulation is like a curry. Okay, so it is like a sandwich type. Why we are going to use this sandwich type? So the gap between the LV and HV is less, air gap is less. Whenever the air gap is less, leakage flux is less, then it has more power transfer capability. Okay, these are the advantage in case of shell type. In case of primary winding, we are using concentric structure. Concentric. Okay, here concentrate on one on another. Okay, so concentric, and here to reduce the leakage flux, we are going with the interleaving procedure. That means half will be considered as HV, half will be considered as LV. Here half LV, half HV. So this half HV will be winding, half of the HV winding is primary side, half of the HV will be in this secondary side. So like that we are going to connect this LV and this LV. Okay, so then the gap between LV and HV is less. The air gap between LV and HV is less. Whenever the air gap is less, then leakage flux is also less. So to reduce the leakage flux, here we are going with concentric and interleaving procedure. Interleaving winding procedure. Okay, that is also very important. So here sandwich type in case of shell type. Okay, so here a small trick is also there. Directly you can give the answer without thinking of all this. Sandwich. Yes for shell type. Okay, concentric. C for core type. Okay, C for C. S for S. Like that also can remember. Okay, answer is option. Coming to the next question. In the following, which is correct? Here IM or IW. IM or IW. I mu or Im. It is nothing but magnetizing component. Magnetizing component of current. Or you can say reactive component or wattless component. Okay, in the same way, IW is working component of the current. Working or wattful component of current. Okay, we know very well in the transformer we have the windings. Windings are inductive nature. So inductive nature means its magnetizing current has be higher than the working component. So if you can consider the vector diagram of this, let us take flux is the reference. Okay, so first of all voltage is leading. Okay, and coming to the no load current. Here the working component of the current or wattful, it will be always resistive component, that is in phase with the voltage, that is IW, and magnetizing component of the current, so that is nothing but reactive component, that is always lagging 90 degrees with respect to the voltage, I mu. So the resultant of this IW and I mu is nothing but I naught. So it maintains nearly 70 to 75 degrees. So as the pi is high or pi naught is high, what about the cos pi naught? Is less now. So that is power factor is less under no load condition. Under no load condition. That is also very important question. Okay. That is also very important question. So in the following, which is correct? Always this I mu is double greater than IW. Okay, double greater than IW. Generally, if you can consider I naught leakage current is, let us take 4 to 5% of full load current. Full load current in these 1 to 2% is IW, remaining 3 to 4% is magnetizing current. Okay, magnetizing current always higher. Always higher. So which is correct? I mu is double greater than IW. So the answer is option C. Answer is option C. Very important question. In case of power transformer, the no load current in terms of rated current. Just now I have given I naught is generally 4 to 5%. So here 4 to 5% means less, 3 to 6% also we can give according to the question. Coming to the next one. The primary and secondary winding of a transformer are wound on top of each other in order to reduce dash. Primary and secondary windings of a transformer are wound on top of each other. That is in the sandwich type of procedure. Why we are using sandwich type of procedure? Why we are using LV, insulation, HV, insulation, LV, insulation, HV, like that. That means why we are using this type of procedure? This type of procedure is used to reduce the air gap between the two windings. To reduce the air gap between the two windings. If the air gap is reduces, leakage flux is less. Leakage flux is less means leakage reactance is reduced. Okay. Coming to the next one. No load current in a transformer is dash. Just now I have given the no load current. This is the pi. This is the voltage. This is the working component. This is the magnetizing component. And this is the no load current. Vector sum of these two. Okay, so this is angle nearly 70 to 75 degrees. So lags behind the voltage by 75 degrees. Okay, so the answer is option A. Coming to the next one. No load current of a transformer has dash. I already said no load current is 4 to 5% of full load current. 4 to 5% of full load current. Okay, so that is, it is small in magnitude. Small in magnitude. And also, what is the angle between voltage and I naught? 70 to 75 degrees. Then what is the power factor? Power factor is less. That is low power factor. So the answer is options. So the answer is option. Okay. Okay, students, we will discuss the remaining questions in the next session. If you have not subscribed this channel, please click on subscribe button and encourage me to take more sessions. Okay. Thank you so much, guys.